Okay, so on this slide, what I want to show you is how small things are kind of on a scale. Um, this slide here shows you how large 1 centimeter is compared to millimeter, compared to nanometer, and then some common items you might be um, familiar with. So here you can see is you got a tennis ball, you have a period, like when you're typing and you put in a period at the end of the sentence, a cancer cell, bacteria, the SARS-2 virus, some antibodies, glucose, and then, of course, the smallest, which is an oxygen molecule in the O2 form. And it's got the size, and you can see we've got some nanometers. Now, we're dealing with atoms all the time in chemistry, and when we're dealing and doing the calculations and the quantifications, we're dealing with very small numbers. So when we're dealing with small numbers, there's lots of zeros. When you're dealing with very large numbers, there's lots of zeros. And those zeros can be a nuisance when you're doing the math and you're converting from unit to unit back into other units. And we don't like to always have those zeros. So if you look here, so say I'm converting and seeing the relationship between a millimeter and a nanometer, you can see that 1 millimeter has 1,000,000 nanometers. And so we've got lots of zeros. So when we do these conversions, so here the scale shows zero point 0.1 nanometer, that's how large an O2 molecule is, we can convert it into millimeters. And when we do, you can see that in millimeters, it is extremely small. And it's very easy to lose some of those zeros. So to fix that and to simplify it, we have created scientific notation so that we can cut out all of those nonsense zeros, because really those zeros are only placeholders. They don't really tell us a lot other than telling us how big or how small something is. So we have the scientific notation to cut out on the excessive use of zeros.